Good morning, everyone. And thank you. I kind of found myself in this set of talks, not because I'm any particular expert in data visualization, or for that matter in data at all. So I think it's just a point that conveniently I could talk about because of some of the work we've been doing in CEDAR. So let me just tell you what my talk is going to be about. It's very much about our experiences in CEDAR and how we've used some of our basic research in diet particularly and translated that for the public or in one case for policymakers. So I'm not going to get into the technical aspects of data visualization or actually the research on which the data visualization is based. I'm happy to talk about that to you personally or at another time. So what is data visualization? Well, it's visualizing data, often quantitative information, to communicate meaning. I mean, this is kind of not very helpful definition. This is actually part of the definition on the website Seeing Data, which I recommend that you look at if you're interested in this area. But if you go further, what you can really see is about helping people, and I'll get to that later, the who I'll get to later, helping people make sense of data and also allowing the ability to examine large amounts of data at once. And this is really about making data more accessible. So this isn't really new. I mean, we've been, as scientists, we have a long tradition of converting our observations, our theory, our measurements into visual representations, going as far back as the heliocentric conception of Copernicus in the Renaissance to Charles Darwin's first stab at phylogenetic relationships in the 19th century, and then more recently the visualization or the representation of the double helix. So this is not our area of research, of course, so we're in population science, and population science, I would say, is about patterns, associations, and relationships. And that's exactly the kind of stuff that lends itself very well to visual representation. So for example, we're in the John Snow Lecture Theatre, so of course many of you, all of you will know about John Snow's documentation of cholera cases and the representation of those on the map of Soho. But you can also look at more recent examples, in this case looking at genetic loci associated with obesity, looking at, in the bottom right, looking at networks and relationships among obese people in a community, or more recently looking at the share of disability life-adjusted years attributable to different health problems. So these are all scientific figures, and I would argue they're also part of data visualization if we define it in this broad sense. So, but that doesn't really get, in my view, to the heart of what data visualization can accomplish. So what do you want data visualization to do? So it depends on your audience. So I would say that the three chunks of audience that you might want to pay attention to is the researchers, that's us, and many of us, not all of us, I know. But as the examples I've given, part of what they're for, those visualizations are for, is to understand data and develop new hypotheses. I'm not going to talk that much about that audience. There's the public. As publicly funded scientists, part of our obligation to society is that we engage with the public about our data and our area of research. And finally, policymakers. I think many of us in public health are very interested in seeing our research translated for the benefit of society. And part of that involves making our primary research more accessible to the public. So I'm going to talk about primarily the public and the policy circles in this Venn diagram, and narrate that through three case studies that we've had in CEDAR to date. So the first case study is related to our ongoing work on inequalities in diet. That's a big part of our research program, at least my research program in CEDAR. And it all starts innocently enough. You have you want to do a study, you want to have initially a descriptive characterization of social inequalities in diet. Okay, what do? You need data. So in this case, this is a study that was led by one of my PhD students, should be up here, Eva McGuire. And it relied on primary analysis of National Diet and Nutrition Survey, the rolling program. So there's, all of you have been in this place. There's infinite number of ways you can set up a paper. How do you structure the analysis? What's the story? So in this case, we wanted to characterize social inequalities using 3 dimensions of social position in relation to 5 dimensions of diet. So that's a story into itself. But that's already itself a lot of data. And this is by any means the totality of the data. But you can see that when you're talking about this much data, in a traditional scientific paradigm, you're kind of forced into these very information-dense exhibits, which are, not very appealing to most people. But this is a way of describing your data, the social patterning of food consumption, but definitely not user-friendly, certainly not really good for public engagement. And we think this is an important area of science, and we want to communicate this to the broader audience. So what we want to do then is build on this and maybe do some more outreach. And one way to do that is to write a blog. Even I wrote a blog about this. It was written, we wrote it for the Nutrition Society, but then it was syndicated. It ended up in a few other places. Okay, that's a little bit more of a ripple. But it's really by no means the end of the story. So we, based on the feedback we got from the reviewers and also subsequent feedback we had from other scientists, the question kept coming up, okay, well, why did you choose those 5 foods? What happens if you look at this, or what happens if you look at that? And we know that there are lots of ways of doing this. So how do you do that? How do you sort of characterize social patterns of food consumption in a way that you can kind of quickly and easily see what's going on? We thought we had already gone quite a length by going well beyond fruit and vegetable intake, which is often what people look at. So together with Nick Jones, another PhD student in my group, and Oliver Francis, who's our head of communications and knowledge exchange, we ended up with this. This is basically a variation of a bubble plot. So a bubble plot is simply showing information about magnitude of something in relation. It's proportional to the diameter of these circles. And oftentimes there's information on the x and y axis. We kind of perverted the idea a little bit because the information on the x and y axis is not a continuous factor. It's categorical. And so what we did is we studied income and education, and we stratified, again, the same data set, National Diet and Nutrition Survey, by 3 levels of education and 3 levels of income to create 9 social groups. And then we represented the data, in this case, the consumption of food above and beyond the sort of the mean intake for the UK. We represented that as a proportional to the diameter of each of those circles. And then we color-coded based on food groups. So we learned a lot from doing this because circles are very hard visually for people to interpret. And also the way we transformed our statistical information into these circles can lead to a lot of really misleading and bizarre conclusions. I know it's very difficult to really see what's going on up here, but so this is sort of the most advantaged group up here. It's the most educated with the most income. And you see, the first thing you should just be able to see is a lot more color in that group, in that cell, which means there's a lot more food groups and foods that are consumed above and beyond what the general population is consuming. But they're also consuming a lot of, or what looks to be a lot of certain things like smoothies. But again, the smoothies are not proportional to the amount of smoothies, how much more that's being consumed than the average. So you might take away from this, if you look at it very superficially, that people are taking baths and smoothies, for example. And there's also things like game birds up here, which you think people are eating game birds every day, which they're not. So this is one of the lessons for us was that we're not very well suited visually to see quantitative information. At least in this way, this is not very good. So I would say this is a very good qualitative. It's taking quantitative information and turning it into a qualitative statement. So for example, if we zoom in on the bottom left corner, sort of the people with least education and least income, we can say that they're eating more kind of takeaway type foods. Look at these things like coated chicken, which is like fried chicken, bacon, ham, sausages, fried fish, and they get more trans fats and maybe consume more whole milk. So I think that's a safe statement to conclude from that. I wouldn't by any means put any kind of number on that thing. So we learned a lot from this in what we could and could not interpret from this type of visualization. That's sort of the scientific part of that. The public part of that was quite striking. I mean, this is really one of the most, to us, informative lessons about how to get reach. So when this went active about 2 years ago, actually now, the result was really huge, and we didn't see that coming, and quite quick. So it got picked up by, well, it got picked up by social media, it got picked up including Twitter and blogs, it got picked up by the new sort of traditional news outlets, and it also got picked up by Reddit, which some argue is the front page of the internet. So you can see here, for example, this is just the number of hits on our CEDAR website. This is when it went live, and it accounted for, since it was published, it accounted for 22,000 visits to our website, which is even to this day, our website is almost 5 years old now. It's still half of the traffic we've ever had on our website. So, and it still gets regular visits, just not quite as much as then. And the other nice thing is one of our sister institutions, Fuse, up in the Northeast, wrote this very nice blog piece about it. They called it a blow for translational research. And they made this nice statement about it, that it's a wonderful case of the picture holding your attention much better than any sort of traditional table numeric way of representing data. So it really kind of was a good lesson for us in a number of ways. So the next example or case study I'm going to talk about is our work, again, ongoing work that we do on food prices, because we think that's an important public health issue. So again, we start with a piece of primary research, which we thought was kind of a piece of novel, kind of interesting, because it was a piece of research that was only enabled by linking two data sets that were traditionally not ever brought together. Nick Jones, the student I mentioned before, did this work linking consumer price index data from the UK government to nutritional information from the National Diet Nutrition Survey to allow us to track prices over time in relation to their nutritional quality. So for example, this is one of the figures. You can see that if you characterize foods based on their nutritional quality and use the government criteria to define less healthy foods, you can get kind of a group of foods that are defined as less healthy, and then everything else. This is sort of foods that are, I would say they're not less healthy. They're called more healthy, but they're not necessarily healthy. But we could look at that, we described that, we reported that. That stuff got picked up in the news media. The news was interested in that. And again, the news media and also other scientists were interested in the study and interested in the data. And it got us interested in representing how we could make this information more readily accessible to the public and to other scientists. So we started really putting our heads together to figure out how to represent this in an interactive and user-friendly way. And to do that, we started at the whiteboard, and we started thinking about how we would do it that would make sense and allow people to kind of explore the data in a very easy and attractive way. And there's a lot of questions here, really. I mean, you, for example, want to know who do you want to use this? Researchers, public. And so you want to know your audience, but you also want to, in defining and informing this kind of visualization, you want to have certain people in the room. You want to have the researcher, for example. You want to have someone in communications, and you want to have someone who knows something about computer programming. And it's not always about adding more features. You sometimes want to take things out. So this is where we ended up. This was only launched about a month, 6 weeks ago maybe. And again, just like the last one, I'm showing you stills, screen grabs from these tools. The URL here is on the bottom. You can explore that and play with it whenever you like. But this is a dynamic, interactive visualization that allows you to examine food price changes in the UK for about 100 different food items. This is all government data. But again, we've classified foods into 5 food groups, and we've also classified them dichotomously based on the government's criteria for nutrition, based on a nutrition profile, the FSA Ofcom score. So it's quite flexible. You can define the price change in terms of relatively or based on pounds and pence. You can define any number of different parameters. You can look at different years, and it all updates live as you manipulate the controls. So it's, as I said, quite recent, but one way that, and it's hosted on another website, so I haven't looked at see how much traffic it's generated, but one way we've looked at the assessment or its uptake is just by looking at Twitter data, and so we've had about 40-something thousand impressions, which is kind of a marker of visibility. So it's gotten some attention, but I think that this is, again, an example of making data available both to researchers who have approached us and also to the public to allow them to really see what's going on for themselves. So finally, the last piece of work is work that it builds on some of the primary research that we've been doing, especially work led by Tom Burgoyne, who's here and is part of the network. We're interested in food environments and that how they contribute to diet and unhealthy eating and obesity. So some of you, I know, also work in this area. This is an example of some of the work we've done where we characterize people based on their exposures to fast food outlets around their home and their workplaces and their commute routes. And then we ranked people based on how much exposure they had, and we looked at that. We had looked at multiple outcomes. One of the outcomes we had was the consumption of energy-dense takeaway food. We saw kind of systematic dose-response associations with exposure, and again with BMI, we found the same thing. We saw the same thing with odds of obesity. And that publication also generated some media attention, which was nice. But in this case, that's not what we were really interested in. What we were really more interested in is the background policy context to this work. So, for example, National Obesity Observatory and now Public Health England have this is really high on their agenda. They're really interested in monitoring the food environment, particularly fast food outlets, and informing policy action on that. So you can look, for example, in this area, in the Greater London Authority published this report about 3 years ago describing a sort of roadmap for local authorities to take control of their local food environment and use existing planning authority to shape and improve the food environment. So a more concrete example of that is what Birmingham has been doing. Since 2012, when they issued this supplementary planning document, they've been trying to curb the proliferation of takeaways in areas that are already saturated. So, for example, they want to refuse planning permission, and I don't have more up-to-date data, I'm afraid, but as of mid-2014, out of 36 applications that were made for new takeaways, almost half of those have been refused. So how do you do this? How do you know where to target these policies? Where are these places that are already saturated? Well, I mean, many of us might know, we might live there or work there. But if you want to look at this systematically, what are the tools to do this? How do local authorities inform these policies? So, for example, in Newham, which is one of the boroughs here in London, they've got their own in-house technical staff, GIS people, who can generate these very sophisticated maps that locate where their schools are, a vulnerable population, you might argue, in relation to hotspots of takeaway food outlets. Not all local authorities have this kind of resource, and so where are other local authorities to turn when they want to inform policies like this? So again, together with Tom, we wrote a small grant to inform the development of a new tool for this type of policy. We call it FEAT, the Food Environment Assessment Tool. It's not live yet, but we've got a pilot version running on our internal servers and that we take on the road. I'll tell you more about that later. But this is, for example, what FEAT can do. The purpose of FEAT is to provide quantitative and objective measurements of the food environment defined in a number of ways. That's flexible. That can be aggregated at different geographies. So right now what I'm showing you is a sort of picture of the Greater London area and part of the southeast. And these are, you can see the London boroughs. I'm not expecting you to be able to look at this, but these controls let you specify the level of geography to analyze what types of food outlets you're interested in, whether to standardize the information about food outlets either in population terms or in relation to the overall food environment. And then there's sort of data displays down here, histograms and a legend, color-coded legend. So let me just draw your attention to where we are. We're there. That's the borough of Camden. And right now what I'm showing you are takeaways that are just counted up within each of the borough boundaries or the local authority boundaries. So it's quite basic, just counts of takeaways. However, you can standardize it And actually what you see is you get these really red hot areas that are kind of central London. Not that surprising, not that interesting. You can also standardize that information against the total food environment, meaning all other food outlets, and you get a very different picture. So for example, now what we're looking at is takeaways as a % of all other food outlets. Let me just toggle back, forward. And you can see the histograms updating there. So these are, again, just stills from a dynamic tool that people can use. And again, now that we look at it that way, Camden doesn't look so bad. It's only, according to this statistic, about less than 20% of the food outlets are takeaways in this tool, according to this tool. And again, I forgot to mention, this tool is based on data from the Ordnance Survey, so it's up-to-date food environment outlet from the points of interest. So, but to me, this is not really the interesting part of it. This is kind of, let's zoom in a little bit. So there's Camden again. We can look at it again. We're still looking at the entire borough with data aggregated at that level. But more interestingly, we can start to look even finer. We can look at, there we are, sorry. And then we can look at LSOA levels. So now these are LSOA data. So what's happened now is we've counted, or we're measuring the % of takeaways within every LSOA, both in Camden and out everywhere in this frame. So that's another level of analysis that, again, isn't that interesting to me, but it might be interesting to some of the users. We're in the process of finding out. So again, there's where we are. There's our LSOA, and according to this statistic, we've got 2 food outlets in this patch, and one of them is a takeaway. So we've got a 50% takeaway. But from a geographic point of view and from a causal inference point of view, if you're interested in understanding how these as exposures, it's kind of, to me, tenuous, because you can just see is the geographic problems here. You've got big discontinuities between one area and the next. It's not very, from an epidemiological point of view, that interesting. But if we zoom in closer, let's show the frame of where we're going to zoom. We're getting close to finishing here. Now we can zoom in and get much more fine information about the surface, almost, of this area. So for example, this is now the frame that I zoomed in on. There's Regent's Park. We're here somewhere. I'll show you in a moment. But now this is the same information. This is % takeaways. But what we've done is we've computed that for each unit postcode, 7-digit postcode, but not counting up the food outlets in the postcode. What we're doing is buffering each postcode with a standard size buffer, and then going to the next postcode, buffering that. So you move the buffer along with every postcode, and you end up with what amounts in an area like London or any urban area, almost like a surface. So, and there we are. And according to this, we're not so bad. But you can see this big gradient from to the east, where you've got higher levels of almost 30% of the outlets takeaways to here, where you have about 15 or 16% takeaways. We're at about 20% here, where we are sitting right now. So actually, I think I got the wrong postcode because of I thought we were going to be in the other building. So anyway, let me just conclude by saying what are the key points. I'd say we can use data visualization to engage with other researchers. That's great. I think that helps us build more interesting research in the long run. With the public, we can increase the visibility of our work, and I think that's all part of our jobs as publicly funded researchers. And I think it also presents, for public health, this is vital, opportunities to work with policymakers to provide them information they need in a more usable way. And, but that relies on you having that conversation with them. In fact, FEAT, we developed an initial dialogue with our local authority stakeholders in Cedar. So that evolved quite organically as a process. And I would say the other key question is it takes a team. Sorry, that's just that again. That's remembering your audiences. It takes a team to do this kind of stuff. So I could never have done it by myself. Tom couldn't have done it by himself. You know, we're very fortunate in Cedar. We've got all these people around, and we can work together on this. But that's one of the things that I think is a big challenge, because none of us individually are well suited as individuals to do this all by ourselves. So I'm just going to leave it for that. And again, I'm happy to pick up questions. I want to acknowledge my team here, acknowledge my funders in Cedar, but also particularly my students, Eva McGuire, Nick Jones, Tom, who's in the back, and our head of communications and knowledge exchange, Oliver Francis. And then take questions now or at the break. Thank you.
Thanks, Pablo. Does anyone have any questions, Pablo, just for 5 minutes or so? No? Susan.
Thanks, Pablo. That was a really interesting presentation. I just wanted to ask about the responsibility of keeping these data up to date when they're publicly facing. So in terms of policymakers keeping the fee tool up to date and even the pricing data, and then the burden on academics to do that, and that trade-off, I guess.
Yeah. I'm not mic'd anymore, but just let me know if I need to repeat myself. Yeah, it's a great question. We've talked about that sustainability question quite a lot internally, because we've got initial money to create the pilot, but we don't have a long-term funding model for it. But our hope is that if we can demonstrate that it has usefulness to the intended users, then we're going to worry about that later. But I think that's essential, because if you don't keep something up to date, it's hopeless. It's not going to be useful in the long run. With those other two examples, the social inequalities in food consumption and the pricing tool, I felt like we don't have much ambition for those for the future. I think those are in a sense more of test cases to try to see how we could do and what role these have in outside of our work. But as institutionally, we are getting a green light to spend some of our effort doing this work, because, like I said, it's part of our jobs, and public engagement